All right, so this is the first of three of the chemistry lectures. And first of all, you should know this. It turns out this is a prereq for the course. And so one semester, I got the great idea of just skipping it, thinking, oh, they should know it. But that did not go well. So we are going to go over some just real basics of things that we will need you to know for the biology portion. And this is my kind of plug. One of the things that I find out that students do is, and I did it as a student, is you learn things in little boxes for the test and maybe for the final, and then you slide it under your bed and not worry about that box anymore. I am going to suggest that you try to remember. Yeah, I know education is a novel thing. But actually, it'd be more helpful that if you take new information and put it on top of the old information, it actually makes life easier. So let's look at chemistry. This is pretty cool. Here are some ants using a chemical defense. So there is something coming out from the sky. They don't really show what they're shooting at, but they're having chemical weapons. So kind of cool. All right, so let's do some basic definitions. The first one is matter. And matter is anything that has a mass and takes up space. And so that is real simple definition. And then we're going to look at atoms and elements. All right. So first, let's start with the elements. And there are many of them. And there is the periodic table, which I'm going to want you to be able to read. I will not make you memorize it. I think there are actually some chemistry teachers on campus that do and others that don't. But I would like you to be able to use that. I have one in the module, and we will go over that on the first day also. So no worries. But what I do want you to know, there are essential elements that that we need, and then there are some trace elements. So what I do want from you or need you to know is that I'm going to give you the word chinops, which you see on there, and that stands for the 6 elements I want you to know. Carbon, hydrogen, nitrogen, and oxygen, you can see on the diagram there, it says 96.3% of the human body, and that's fine, that's true. But I'm going to give you another number that's not actually in the textbook, and that is 98%. And what I want you to add to that then is phosphorus and sulfur. That is going to become important later. So if I ask you what makes up 98% of the human body or life, I want chinops. And it will make a difference later when we talk about it. All right, so other definitions you need to know. Molecule versus a compound. And sometimes they seem to be used interchangeably, but a molecule is basically a substance made up of 2 or more atoms. And then a compound is made up of multiple atoms of 2 or more elements. So if we look at an oxygen is O2, that would be a molecule because it's made up of 2 atoms, but it's only made up of 1 element. So that is not a compound. NaCl then would be think about it, compound made up of 2 atoms, but also made up of 2 different elements. The key here is, and might as well do water too. So water is also a compound because it's made up of 2 elements and 3 atoms, but you've heard of water molecules. Both of these actually are also molecules. This is the molecule of salt, table salt, and this is the molecule of water. So again, be able to know the difference. And then we'll look at atom structure. Very simple, probably taught you in high school, hopefully, but it's very, very simple. And an atom is pretty much made up of 3 basic elements: of protons, neutrons, and electrons. So what I do want you to know is where they're located, what their charge is, and actually what their mass is, or weight, I guess, on this planet. So let's go with protons first. And they are positively charged. They are found in the nucleus of an atom, and they have a mass unit of 1 AMU, atomic mass unit is what the AMU stands for. The older term for that is Daltons. You might still hear that occasionally in some of the older books. All right, a neutron, on the other hand, what I need you to know is it is neutral, it has no charge. It is also found in the nucleus of an atom, and it also has a mass of 1 AMU or 1 Dalton. The last one is the electron. The electrons are negatively charged. They are in a cloud or an orbital or shells surrounding the nucleus. And they do have a mass, but that mass is pretty small. It's like 1/2000th of an AMU or Dalton. So I want you to know that. That will help you when we discuss things. And then here's the periodic table, and we have different terms that I want you to know. And so we will go over this again and maybe in classes to be sure everybody's on the same page. But I have a full periodic table again in the modules so you can take a look at them. But the atomic number, like hydrogen, the atomic number is actually 1. And this one's not as easy to read. I don't like this table real well, but you can see the 1H, so 1. So that means basically atomic number is equal to the number of protons that a element has. And so carbon would have 6 protons, magnesium would have 12, aluminum would have 13. So that's how you read that. The mass number, on the other hand, and be very careful because sometimes it's listed as the atomic mass number. But anytime you see the word mass, they're asking you for well, it's kind of equivalent to weight here on Earth. And so what that number would be including would be not only the protons but the neutrons. So for instance, carbon 12 has an atomic number of 6, so it has 6 protons, and carbon 12 then would have a mass number. The 12 is the mass number, so it also have 6 neutrons, and we'll see that on another slide. The atomic weight is also given on the periodic table that I'm handing out, and that one actually is a bit different because that's talking about a bunch of atoms together, and we'll go into that one when we look at it. But it's basically adding up Avogadro's number of those atoms of those elements. So we'll look at that when we look at the periodic table. And for now, we will leave it at that for this section.